Dear students, good morning. Today we are going to discuss about the architecture and the sources of IoT. In previous video we have discussed about the conceptual framework. It is it is closely related to the architecture because the conceptual framework is the basic building blocks we can say for kind of architecture. Also the sources we are going to discuss. Okay, what are the sources, especially the important cars which is operated in the IoT network. Okay, and architecture has the following features, and the architecture serves as a reference in applications of IoT in services and business processes. A set of sensors which are smart capture the data, perform necessary data element analysis and transformation as per the device application framework, and connect directly to the communication management. A set of sensor circuits is connected to a gateway processing separate data, capturing, gathering, computing and communication capabilities. So these are the very important process. The gateway receives the data in the one form and one end and sends its another form to the other end. In the IoT architecture view, the communication management subsystem consists of protocol handlers, message routers, and message cache. This management subsystem have functionalities for device identity database, device identity management, and access management. Data routes from the gateway through the internet and data center to the application server or enterprise server which acquires the data. And the organization and analysis subsystems enable the services, business process, enterprise integration, and complex processes. So this is the layers of we have the 7 layers coming to the IoT architecture view. That is a reference model we can say. In this level 1, physical devices and controllers are connected and the connectivity, and the level 2 it is the connected, and level 3 it is the edge computing, level 4 it is the data accumulation, and level 5 it is data abstraction, level 6 is application, and level 7 it is the collaboration. This is how the reference model of the IoT architecture. And the architecture view you could analyze, in the last video we have discussed about the conceptual framework. Similar way we have the 6 levels here, that is gather, enrich, stream, manage, acquire, organize and analyze. So we must remember all these 6 stages, that is gather, enrich, stream, manage, acquire, organize and analyze. Okay, and these are the full explanation detail about the architectural view. The architecture serves as a reference in applications of IoT in service and business processes. The gateway receives the data in one form at one end and send it in another form to the other end. The communication management subsystem consists of protocol handlers, message routers and message cache. This is how the process happens. And coming to the sources of IoT, this is a very interesting topic, that is sources of IoT. And here we are using the popular development boards, that is sources in the sense, especially it must be a sensor, and all development boards need an IDE. So I already said that is IDE, that is integrated development environment, that is used to interface the hardware and software here for developing device software, firmware and API, application programmable interface. Okay, and we have some toolkits here: Arduino in, Microdino and Intel Calico, also Intel Edison, and the Beagle board and Raspberry Pi wireless inventors kit. And here, coming to the sources of IoT, the RFID. What is RFID? Radio frequency identification. It is doing a vital role, and where the technology, digital and data encoded in RFID tags are smart, are captured by the reader via radio waves. So we day-to-day life, most of the things, that is especially wherever we are swiping the cards, the RFID plays a vital role, and enabling tracking and inventory control, identification in supply chains, access to buildings, road toll management, yes obviously, secured place entry, RFID based temperature sensors, new applications like factory design, anti-counterfeiting in payment, quality management, and these areas the RFID, it shows it's important. And another most important source is wireless sensor network. Yes, we all knew the wireless sensor network, it's a major role, and also it's a big part coming to the Internet of Things. and a network in which wirelessly connected and have a capabilities of computation for data analysis and communication and networking. Okay, so sensors can be networked by wireless technology. It may be either analog or digital. It can acquire data from remote locations, uses RF receivers, that is radio frequency transceivers. Transceiver in the sense what? Transmitter as well as receiver. And temperature, pressure, metal proximity, and humidity. So these we can have so many kind of sensors based upon our application, and those sensors will be effectively used for the applications. Now coming to this RFID identification, we can have a good example, that is you just see, that is the broadcast processing, how the broadcast is processing in terms of continuous verb. And extension of the wireless sensor network, you just see the general block diagram, general approach of wireless sensor network. So from the user, the this is the region, sensing region we are having. In sensing region, the nodes, sensor nodes are deployed. It may be deployed in a mass manner, or we can have some clustering process, or some rules or algorithm may be there to collect the uniformity of the nodes. Okay, but anyhow, in a region, major sensors are deployed, and it will sense the information in that place. Well, for example, whether for example, in one area, whether the forest fire happens, it will detect and send the information, and it will coming to the base station, where base station receives the information, and it will send to the internet, and internet, it may have the cloud based server or whatever may, and the end user will fetch the information from the internet. So this is how the wireless sensor network is working. Sensors can be networked using wireless technology and can cooperatively monitor physical and environmental conditions. Sensors acquire data from remote locations which may not be easily accessible. Each wireless sensor also has communication abilities, for which it uses a radio frequency transceiver. Each node either has an analog sensor with a signal conditioner circuit or a digital sensor. Sensing can be done to monitor temperature, light intensity, pressure of darkness, and mental proximity, traffic, physical, chemical, and biological data, etc. So, this is how the sources of IoT doing a major role in terms of Internet of Things networks. Thank you. Thank you for your passion.